Okay, so this is an example of a tree diagram probability question for independent events. So basically, whatever happened on Monday, the probabilities won't change irrespective of what happens on Tuesday. So the probabilities on Tuesday won't change. So we'll have a look at how we can put this information into this tree diagram. So it says the probability that it will rain on Monday is 0.6. So we follow that branch, that's the rain bit. So the probability will be 0.6. Each of these branches is coming from an event. So this is what happened on Monday. So the event was, did it rain or not on Monday? 0.6. All events must add up to, all the outcomes from the events must add up to 1. So that must be 0.4. It's given some conditions of what happens. So if it rains on Monday, the probability that it will rain on Tuesday is 0.8. So if it rained on Monday, then the probability that it rains on Tuesday is 0.8. So that's going to be 0.8. Again, these are independent to what happened here. So the event is, did it rain on Tuesday? If it did, it was 0.8. If it didn't, it must be 0.2, because these again have got to add up to a whole one. It then says when it does not rain on Monday, so down here, then the probability that it will rain on Tuesday is 0.5. So not raining followed on Tuesday by rain would be 0.5. Again, these have got to add up to the whole one. All the possible outcomes are known. It'll either rain or it won't rain. So 0.5 plus 0.5 is 1. So that's filling in the tree diagram itself. We do this for a reason, to calculate probabilities of outcomes for combined events. So we're looking at this and it's saying work out the probability that it will rain on both Monday and Tuesday. So we want it to rain on both Monday and Tuesday. So we follow the branches through, and basically it's saying up there it rained on Monday and up here it rained on Tuesday. So this is the outcome that we want to happen, that it rained on both days. And what we've got to realise is that when we come along tree diagrams and come along the branches, then when we get to the end of the branches, then the outcomes the probability of the outcomes are calculated by multiplying the two probabilities, because they're independent of each other. So to get this answer, we'd be doing 0.6 times 0.8, and that's going to equal 0.48. So the answer for work out the probability that it would rain on both days is 0.48. Okay, so that's just a reminder about how you can put numbers into tree diagrams, and then how you can work out a probability of an outcome from two events by following them through. If we'd have calculated the answers for all these possible outcomes, then all of these would have added up to a whole one. And you could do that at the end of the exam if you get time, just to check that it's all working. So that's an example of tree diagrams and calculating probabilities from them.